guys, so building on your lesson from food chains and food webs, we are going to now move into ecological pyramids. Ecological pyramids are models that show how energy flows through ecosystems. The base of each pyramid represents the producers, and each step up represents a different level of consumer. So primary consumer, secondary consumer, tertiary, quaternary. The number of trophic levels in the pyramid is determined by the number of organisms in the food chain or web. Okay, so there's three different kinds of pyramids. First one we're going to start with is the number pyramid. All right, the number pyramid represents the total number of individual organisms available for energy at each trophic level. These can be used to examine how the population of a certain species affects another. So if you look at the pyramid of numbers, the pyramid size is not like a perfect pyramid. It's not a perfect triangle. The triangle or the shape is determined by how many of each thing there are. So if you look at this pyramid, you can notice easily that there are more producers than anything. Then there are more primary consumers, then more secondary, then more tertiary. This is a very common pyramid for many types of ecosystems because producers are much, much smaller and make their own food. So those are trees, grass, and if you look out the window, that's what you see most of. Then primary consumers, then secondary, then tertiary. So here's another pyramid showing numbers. Producers, this is a grassland in the summer. You have producers, and then herbivores, primary carnivores, and top carnivores. So producers, primary consumers, secondary consumers, and tertiary consumers. Here's another one, and this one is different. You notice this one, you look at the blue part, that's the actual pyramid. It's not a pyramid. It's a weird shape. It's almost like a diamond. And it's because this is showing the ecosystem in one single oak tree. So you notice the bottom is a very skinny line. That's just one single tree. And in that single tree, there are tons of caterpillars. And then there's a few birds, the blue-tilt bird. And then there's the sparrow hawk at the very top. And there aren't many of those. So that's what makes a number pyramid not necessarily in the shape of a pyramid, is when you're looking at just one specific tree or one bush or one something or fewer producers than you are anything else. So it can look like this. It doesn't have to be the shape of a pyramid. Okay, biomass pyramid. So the word bio, remember, means living. So living mass. These represent the total mass of living matter. Okay, this is called biomass at each trophic level. So literally, what is the mass of everything that is living? Since the number of organisms decreases as you move up, in this example, so does the amount of biomass. There's less living mass as you move up. Again, here's biomass, and this is in kilograms. So remember, mass is a measurement. Producers at the bottom, then you have herbivores, primary carnivores, top carnivores. And do you notice a pattern in the numbers with each level as you move up? Each level, what number do you divide by each time? What's 1,000 divided by 10? Each time, look at that, what happens? These pyramids do not necessarily represent the amount of energy available at each level, however, because a bird's beak and skeleton do not go towards the amount of energy another animal might get from eating it. So when something eats a bird, it does not digest the hard parts, so the parts that might form a fossil, the beak and the bones. But they do count as the total amount of biomass, because mass is a measurement of how dense something is, okay? So we know mass in terms of grams and kilograms. But the beak and the skeleton do go towards the mass, but not towards the amount of energy something would get from eating it, because it can't digest those. An energy pyramid, this is the next kind of pyramid, the third kind, represents the energy available for each trophic level in an ecosystem. The energy needs of organisms are greater from level to level, and that's because things get bigger. So a blade of grass doesn't require as much energy as an insect. And an insect doesn't require as much energy as a snake. And a snake doesn't require as much energy as a fox. And a fox doesn't require as much energy as a human. So each time you move up to trophic levels, the energy needs are greater. So here we go, showing the energy needs, or showing the amount of energy available, rather. At the bottom, it is 1,000 primary consumers, secondary consumers, and tertiary consumers. Each successive level in an ecosystem can support fewer numbers of organisms than the one below it. Only 10%. And I was asking you a couple slides ago to look at the pattern and notice the number 10. Each successive level can support fewer numbers, and that's because only 10% of the energy available is used in each level of the pyramid. 10% is used in each level. Out of 100%, 10% is not a lot. 90% is lost to the environment as heat energy or thermal energy. Remember, therm means heat. And 90% is lost to the environment. Remember, matter and heat and energy are not created or destroyed, they just change form. So instead of being able to be used by organisms, 90% of it is put back up into the environment. So this is it's called the iron rule of ecology. If you look, that 10% rule, 1,000 kilocalories, primary producers, you move up. Primary consumers, it's only 100. You move up. Secondary consumers, it's only 10. You move up. Hawks, tertiary consumers, it's only 1. Each time you divide by 10. What that means is 10% is available, 90% is lost. So, energy pyramid, this is just another diagram showing you the sun is the main source of energy for all ecosystems because producers are the base of all ecosystems, of all the trophic levels. And if the producers didn't have the sun, there would be no producers, and then there would be no other trophic levels. But notice the arrows off to the right. It's showing you that thermal energy is lost. Okay, so here we put all of them together. This is an awesome diagram. We have a pyramid of numbers on the left, a pyramid of biomass in the middle, and a pyramid of energy on the right. You see a fox, a rabbit, and grass. Pyramid of numbers, pyramid of biomass, pyramid of energy. And then if you look at the bottom, you see sea lion, herring, zooplankton, and phytoplankton. So the bottom one is a marine ecosystem, and the top one is a terrestrial. So the top live on land, the bottom live in the ocean. And you can see that the zooplankton, there are actually more zooplankton than phytoplankton in this specific example. There are the same amount of grasses in each, numbers, biomass, and energy, and then rabbits and fox look similar.